Okay, so once you have the a value, you can then just write the completed equation, which would be, again, square root of y equals, so now that we know the a value is negative 1/5, so put a negative there, 1 here, 5 there, followed by bracket x plus 1, followed by x minus 5. So that seems to be pretty reasonable. Now, what I'm going to try to do is I'm going to see if we can get, oh, look at that. So we managed to get OneNote to come up with the equation there. I'm going to try to plot that and we're going to compare it. Now, the one big challenge here is I got to zoom in quite a bit. So let's see how good we were with finding the zeros. So it looks like my zeros were negative 1 and 5. Let's see what this came up with. So it seems like the zeros here, and I can take a look at some of the key features and show them on the graph. Looks like I was pretty darn close to the negative 1, and then the 5 looks pretty darn close as well. Looks pretty close. So what's going on? So not bad. So that's a good way of estimating. Now OneNote did a huge favor for me that if any of you would like to try using Desmos, I've given you a little instruction here on how to do that, and perhaps I'll do that in another video. But to use the equation to estimate the height of the ball when the horizontal distance is about 1.5 meters, well, that's simply using the graph. Now you can use some technology to do that too. So you would have to essentially, let's go back here and see if I can add this in here. So I can go through, and I'm looking for a horizontal distance of 1.5. So that's the x value has to be 1.5. So that's an x value of 2. 1.5 seems to be 1.75 according to the graph I'm getting in OneNote. So it seems like the estimated the ball is about, let's check that again. So again, horizontal distance is 1.5 meters, so that's your x. Looks like it's about 1.75. Okay, so just to confirm that you can see Desmos at the moment. So these are the data points that I've entered. And for that first example, just to try it in Desmos, so you would have to insert a table in Desmos and then set it up the way I have it here. And I'll be sharing this link file with you. So you'll get the same sort of look in the dots. And then you notice down here, I've got a very funny way of setting up the equation. There's no equal to signs. Little symbol in here helps Desmos determine the equation, and it tells you what the a value is and the r and the s. Now, mine's pretty close to negative 1 and pretty darn close to 5, so it's not too bad. If we click on that, Desmos will actually give us the graph. And then you can use the Desmos function. When you click on it, you can answer the same question we did before. So there's 1.5, we get about 1.8. It's roughly what we had in the OneNote file, and can continue from there. Now the other file, or the other example that we were going to take a look at here, is this one here. Now it's very tedious to enter all that data. So this is a hang glider that's launched from a platform, and there's some data corresponding to it. So you're asked to find the height of the platform. Now the height of the platform if the person is standing at the top and then they jump, then that would be the instant that they start their flight. So the height of the platform should be the same as when the time is 0. Now to find the equation, you could graph this by hand and do exactly what I did in the previous example. We're going to do a little bit of a cheat, I suppose. We're going to use Desmos to help us solve this little problem. So again, switching over here, I've entered the data. Now, once I click on this, you won't be able to see everything, partly because I need to zoom out to be able to get all the data points in here. So I'm actually going to change the settings. So your Y values range from 10 through 56. So I'm going to change the settings here. Make sure the Y values go to at least 60. So I can get a good picture of all the dots. So there's all the dots in there. So and again, you can set up a table. Desmos will give you some headings automatically. And notice the setup down here. I'm using the number 2 where the X's and Y's are, just like in the table, whereas in the previous one I had to use 1s because that's what was required in the table. So actually, make sure those 2 are turned off. So I turn this one on, and you'll notice there's the curve. There's your parabola showing upward trend. There's the A value, 1.2. And the R is something you don't really need to, well, the R value is what we're going to round to about 0.9, and we'll round this to about 9. So we can actually just put in a 1 if you wish. So we got A is 1.2, and one of the zeros is 1, and the other one is 9. So we'll switch back to the other screen and complete the equation. Having on 1.2, 1, and 9. Okay, make sure I got my cursor in the right spot. So the A value was 1.2, one of the zeros was 1. The other one was 9. I'm going to go back just to double check. So again, approximately 1 and 9. Approximately. So that seemed to work pretty well. And back here. So there's a lot of space here because you can solve the question the same way that this one was solved. Up above here, where you're substituting in the values, and that's typically how it would be done on a paper and pencil solution. Now, determine the lowest height of the glider when it occurred. So if we go back to the wonderful little Desmos function here, I think it's pretty obvious that the lowest point would be this special point there, which is your vertex. And just keep in mind which number is which. So there's 2 numbers indicated. So the 5 is the X and negative 20 is the Y. So I know it seems kind of weird, but the Y value here is what we really need. And I'll tell you the reason in a second. So the Y is the height. Now remember, the height is the height indicated. Notice here the values for the height are negative. So just to make sure you've got this information here. So values for the height are negative whenever the hang glider is below the top of the escarpment. So the lowest height and when it occurred was 20 meters below the escarpment. occurred at, oops, no spelling error. And occurred at, just to verify, we will quickly go back at 5. Seconds would be the key units, just to verify. Time is in seconds, head is in meters. So as far as the practice questions are concerned, feel free to use a little bit of technology to get through some of them, but you should be practicing paper and pencil as well.